Today we are going to learn about mastering TensorFlow callbacks for efficient training. We will explore how to effectively use TensorFlow callbacks to optimize and customize your model training process. Welcome to our video on mastering TensorFlow callbacks for efficient training. In this video, we will dive into the world of TensorFlow callbacks, a powerful feature that allows us to optimize and customize our model training process effectively. Callbacks are functions that can be applied during the training process to automate tasks and enhance model performance. Throughout this video, you'll learn about the different types of built-in callbacks available in TensorFlow, how to use them to prevent overfitting, save models, adjust learning rates dynamically, and much more. By the end of this session, you'll be equipped with the skills to implement and customize callbacks to improve model efficiency and reliability. TensorFlow callbacks are an essential tool for anyone looking to optimize their machine learning models training process. But what exactly are they? Simply put, callbacks are functions or blocks of code that are executed at specific stages during the training of a model, such as at the start or end of an epoch, after a batch of training, or even at the end of a training run. They are designed to monitor and improve the model's performance by automating tasks that would otherwise require manual intervention. Callbacks integrate seamlessly into the training loop and can be used to control various aspects of the training process, such as adjusting the learning rate, saving model checkpoints, and even stopping the training early if the model's performance stops improving. The benefits of using callbacks are manifold. They save time, reduce human error, and allow you to focus on more critical tasks like model architecture and data preprocessing. Some common use cases for callbacks include logging training metrics, visualizing training progress, and dynamically adjusting hyperparameters. By understanding and leveraging TensorFlow callbacks, you can significantly enhance your model's efficiency and reliability, making them an indispensable part of your machine learning toolkit.
TensorFlow provides a variety of built-in callbacks that cater to different needs during the model training process. These built-in callbacks are designed to handle common tasks and challenges faced during training, making them incredibly useful for both beginners and advanced users alike. Some of the most popular built-in callbacks include early stopping, model checkpoint, learning rate scheduler, tensor board, and reduceleron plateau. Each of these callbacks serves a specific purpose and can be easily integrated into your training loop. For example, early stopping is used to halt training when a monitored metric stops improving, thereby preventing overfitting. Model checkpoint allows you to save your model at various stages during training, ensuring that you don't lose progress in case of interruptions. Learning rate scheduler enables dynamic adjustment of the learning rate based on a predefined schedule, which can help improve convergence rates. Tensor board is a visualization tool that allows you to track and monitor training metrics in real time, providing valuable insights into the training process. Reduceleron plateau reduces the learning rate when a metric has stopped improving, helping the model to converge better. Implementing these callbacks is straightforward, as TensorFlow's API provides robust support for them. By understanding the functionality and use cases of these built-in callbacks, you can leverage them to streamline your training process and enhance model performance. One of the most common challenges in model training is overfitting, where the model performs well on the training data but poorly on unseen data. This is where the early stopping callback comes into play. Early stopping is a powerful tool that helps prevent overfitting by stopping the training process when a monitored metric, such as validation loss, ceases to improve for a specified number of epochs. This ensures that the model does not continue to train on noise, which can degrade its performance on new data. Configuring early stopping is simple and involves setting parameters such as monitor, patience, and min_delta. The monitor parameter specifies which metric to track, patience defines the number of epochs to wait before stopping after no improvement, and min_delta sets the minimum change to qualify as an improvement. To implement early stopping in TensorFlow, you simply need to include it in your training loop's callback list. By adjusting these parameters, you can control the sensitivity and responsiveness of the early stopping mechanism to suit your specific needs. For instance, in a practical example, if you're training a model and notice that the validation loss stops decreasing after the 10th epoch, you can set the patience to 5, allowing the training to continue for 5 more epochs before stopping. This not only saves time and computational resources but also helps in achieving a model that generalizes better to unseen data.
The model checkpoint callback is an essential tool for anyone working on model training, as it provides a way to save your model at different stages during the training process. The primary purpose of model checkpoint is to ensure that you have a saved version of your model that you can refer back to in case your training is interrupted, or if you want to revert to a previous state. Configuring model checkpoint involves specifying parameters like file path, monitor, save_best_only, and mode. The file path parameter defines where the model will be saved, monitor specifies the metric to track, save_best_only allows saving only the model with the best performance, and mode determines whether to maximize or minimize the monitored metric. Implementing model checkpoint in TensorFlow is straightforward. You simply include it in the list of callbacks when calling the model's fit function. Once configured, TensorFlow will automatically save the model at the end of each epoch, based on the specified conditions. Restoring a saved model is equally simple, allowing you to load the model from the saved file and resume training or use it for inference. Some best practices for using model checkpoint include regularly monitoring your disk space, as saving multiple versions of a model can quickly accumulate large amounts of data, and using the save_best_only option to conserve space by keeping only the most optimal model. By understanding how to implement and configure model checkpoint, you can ensure that your model training is resilient and protected against unexpected interruptions.
The Learning Rate Scheduler callback is a versatile tool that allows you to dynamically adjust the learning rate of your model during training. Adjusting the learning rate is crucial because it can significantly impact how quickly a model converges and its overall performance. A learning rate that is too high may cause the model to overshoot the optimal solution, while a rate that is too low can result in slow convergence. The Learning Rate Scheduler callback lets you define a custom function that modifies the learning rate at each epoch based on your chosen schedule. Configuring this callback involves specifying the schedule parameter, which is a function that takes the current epoch and current learning rate as inputs and returns the new learning rate. This flexibility allows you to implement various learning rate schedules such as step decay, exponential decay, or even cyclic learning rates. For instance, you can set up a schedule where the learning rate decreases by half every 10 epochs, encouraging the model to make more precise adjustments as it approaches convergence. Implementing the learning rate scheduler in TensorFlow is simple. You include it in your training loops callback list. The impact of a well-tuned learning rate schedule can be profound, leading to faster convergence and improved model accuracy. By understanding and customizing the learning rate scheduler callback, you can fine-tune the training process to achieve optimal results. TensorBoard is an invaluable tool for anyone working with TensorFlow, as it provides a comprehensive suite of visualizations that enable you to monitor and analyze your model's training process. Utilizing the TensorBoard callback allows you to log training metrics, such as loss and accuracy, which can then be visualized in real time. This visualization helps you gain insights into how your model is performing and identify potential issues early on. Setting up the TensorBoard callback is straightforward. You configure it with parameters such as log_dir, which specifies the directory where the logs will be saved. Once configured, you include the TensorBoard callback in your list of callbacks when calling the model's fit function. As your model trains, TensorBoard will log the specified metrics, which you can then view in your web browser by launching the TensorBoard server. The visualizations provide a wealth of information, including line charts for metrics over time, histograms of weights and biases, and even computational graph visualizations. Analyzing these metrics allows you to make informed decisions about adjustments to your model or training process, such as modifying the learning rate or adjusting the number of epochs. The benefits of using TensorBoard are numerous. It provides an intuitive way to understand complex training dynamics, facilitates debugging, and aids in model comparison. By leveraging TensorBoard, you can enhance your model training process and achieve better results. While TensorFlow provides a robust set of built-in callbacks, there are scenarios where you may need to create custom callbacks to meet specific requirements. Custom callbacks are particularly useful when you have unique tasks or monitoring needs that are not covered by existing callbacks. Creating a custom callback involves subclassing the tf.keras.callbacks.callback class and defining methods corresponding to the stages of the training process you want to intervene in, such as on_epoch_begin, on_batch_end, or on_train_end. The flexibility of custom callbacks allows you to perform a wide range of tasks, such as implementing custom logging, dynamically adjusting hyperparameters based on custom logic, or even integrating external monitoring tools. For example, you might create a custom callback that sends a notification to your email or phone when the model reaches a certain accuracy, or one that adjusts the dropout rate based on the validation loss. Once you've defined your custom callback, integrating it into your TensorFlow training loop is as simple as adding it to the list of callbacks in the model's fit function. However, testing and debugging custom callbacks can be challenging, so it's important to thoroughly test them in a controlled environment before deploying them in production. By understanding how to create and integrate custom callbacks, you can tailor the training process to your specific needs, allowing for greater flexibility and control over your model's performance.
Using multiple callbacks in a training session can offer significant advantages by allowing you to handle various tasks simultaneously, such as saving models, adjusting learning rates, and logging metrics. However, it's crucial to approach this with a strategic mindset, as poorly managed callbacks can lead to conflicts or unintended behavior. When combining multiple callbacks, it's important to be aware of how they interact, as certain callbacks might affect others. For instance, a learning rate scheduler callback that adjusts the learning rate might conflict with a reducer on plateau callback if not configured carefully. Prioritizing callback execution is another critical aspect. Ensure that callbacks that need to execute before others are placed earlier in the callback list. To avoid common pitfalls, such as callbacks overriding each other's outputs or causing redundant operations, it's essential to thoroughly understand each callback's functionality and configure them accordingly. Additionally, optimizing callback configurations can enhance performance. For example, selectively logging only essential metrics in TensorBoard to reduce overhead or adjusting the frequency of model checkpoint saves to conserve disk space. By following these best practices, you can effectively manage and optimize the use of multiple callbacks, resulting in a more efficient and robust training process.
In conclusion, mastering TensorFlow callbacks is a crucial skill for anyone looking to optimize and customize their model training process. Throughout this video, we've explored the various built-in callbacks available in TensorFlow, such as early stopping, model checkpoint, learning rate scheduler, and tensor board, and how they can be used to automate tasks, prevent overfitting, and enhance model performance. We've also discussed the importance of creating custom callbacks to address specific needs and best practices for using multiple callbacks together. By understanding and leveraging these powerful tools, you can significantly enhance your model's efficiency and reliability, ultimately leading to better results. We encourage you to experiment with these callbacks in your projects and explore further learning opportunities to deepen your understanding of TensorFlow. Thank you for joining us, and happy training.